Good morning, everybody. Welcome to the lecture on spine. This lecture will cover the following topics: the spine, structure and function; vertebra and intervertebral disc, structure and function; the cervical, thoracic and lumbar spines, each of which will be discussed with regard to the structure and function. And the final topic would be the degenerative disease of the spine. The spine or the backbone is the central support structure of the human body. Spine basically connects different parts of the musculoskeletal system. The spinal column consists of the vertebra, the intervertebral disc and the spinal cord. The vertebral column surrounds the spinal cord, which travels within the spinal canal formed from a central hole in each vertebra. The spinal cord is the main pathway of information connecting the brain and the peripheral nervous system. The spinal cord is part of the central nervous system that supplies nerves and receives information from the peripheral nervous system within the body. The primary functions of the spine are to provide protection to the spinal cord, the nerve roots and several internal organs of the body. The next function is to provide support and balance to maintain an upright posture. And the third is to enable sufficient physiologic movement and flexibility. Let us come to the structure of the vertebral column. The figure presented on the left hand side consists of the vertebral column, wherein there are four regions: the cervical spine section, the thoracic spine section, the lumbar spine section, and finally the sacrum and the coccyx with the pelvic bone. The main region of the spines or the sections of the spine consists of the cervical, thoracic and the lumbar spine. So, the human spine consists of 33 vertebrae, each one stacked over the other. So, the cervical vertebra or cervical spine section consists of 7 units, C1 to C7. The thoracic vertebra consists of 12 vertebra. They are numbered T1 to T12. The lumbar spine section consists of 5 vertebra from L1 to L5. The sacrum section has 5 fused bones, that is towards the end of the spine, and finally the coccyx, which contains 3 to 4 fused coccygeal segments. A healthy spine has 3 natural curves as shown in the figure that resemble an S shape in the sagittal plane. So, these curves represent an S shape in the sagittal plane, and these curves help to absorb shocks on the body, and it protects the spine from injury. Let us come towards the end of the spinal cord or the vertebral column, wherein we have the sacrum and the coccyx. The sacrum is a large flat triangular shaped bone nested within the two pelvic bones on either side and positioned below the last lumbar spine, that is lumbar vertebra L5. Connection with the iliac bone somewhere here and here on either sides forms the sacroiliac joint on both sides. The pelvic girdle comprises of the sacrum along with the coccyx and the two sacroiliac joints. The coccyx, commonly known as the tailbone, is the final segment of the vertebral column. It comprises of fused coccygeal vertebra below the sacrum. So, it is located below the sacrum, attached by fibrocartilaginous joints, which permits very limited movement between the sacrum and the coccyx. Let us come to the relationship between the structure and function of the spine. The structure of the spine can withstand the combined load of the head, shoulder and thorax, that is the upper part of the body. So, the weight of the upper part of the body is transferred to the lower extremity through the sacrum and the pelvis. The resistance offered to the axial loads by the spine is primarily due to the S-shaped curved structure and due to increase in mass, size and load carrying capacity as a whole of each vertebra when we move from C1, the first cervical vertebra, to the last L5 and further to the sacrum. The increase in size, mass and load carrying capacity is responsible for offering more and more resistance to the axial load on the spine. The elasticity of the spine is accomplished also by the curved shape of the structure and multiple motion segments, which are known as the functional spinal units. Now, what is this functional spinal unit? This functional spinal unit, or FSU as we always call it, or the motion segment, is the smallest segment of the spine that exhibits biomechanical characteristics similar to those of the entire spine. So, the FSU consists of two adjacent vertebrae, an intervertebral disc located in between the two vertebrae, and two facet joints with ligaments. Two facet joints with ligaments, but without any muscles. You can see in the image presented in the slide to the left, the spinal cord is passing through the FSU, basically through the spinal canal. Let us now come to the facet joint. We mentioned facet joint in the functional spinal unit. What is this facet joint? Facet joint are a set of synovial joints. Now, this vertebra is generally considered as a fibrocartilaginous or cartilaginous joint with very limited movement. Within this vertebral column, the facet joints are a set of synovial joints that limits the amount of motion of the vertebra in 6 degrees of freedom and act to transmit loads to the disc. The different parts of the facet joint are presented in the image of the slide, and if we just enlarge one facet joint, which is basically formed by two facets, combination of two facets. If we enlarge the joint capsule, we see the synovial cavity in the facet joint. The facets which form the facet joints are basically stabilizing structures and carry almost one third of the total compressive load borne by the spine segment. Let us now discuss about more in detail the structure of the vertebra. A vertebra consists of the following bony structure. The vertebral body is located on the anterior side of the vertebra, whereas the vertebral arch is located on the posterior portion of the vertebra. The vertebral arch in the posterior portion consists of 4 articulating facets, 2 superior and 2 inferior, 2 pedicles and lamina, 2 transverse process and 1 sphenious process. The vertebral body is actually a cylindrical mass consisting of a core cancellous bone contained within a thin shell of cortical bone. Now, it has an inferior surface and a superior surface which are slightly concave in shape, and they are known as vertebral end plates. Within these 2 vertebrae, there is the intervertebral disc, and we have the articulating facets that forms the facet joints. Now, let us discuss more in detail about the intervertebral disc. The intervertebral disc, as shown in the figure, is also known as IVD. In short, is a fibrocartilage that lies between the 2 vertebrae in the vertebral column that we have already observed in the slides presented earlier. Now, each disc forms a fibrocartilaginous joint, a symphysis, which allows only a slight movement of the vertebra, very slight movement of the vertebra, and it acts like a ligament to hold the vertebra together. It also functions like a shock absorbing spacer within the spinal column. The intervertebral disc consists of 2 distinct parts, the annulus fibrosus as shown in the figure and a nucleus pulposus. So, the nucleus pulposus is enclosed within the annulus fibrosus. The intervertebral disc displays viscoelastic material behavior. This in particular, they exhibit creep and stress relaxation mechanical behavior. The annulus fibrosus, as shown in the figure, consists of several concentric layers of fibrocartilage with annular fibers embedded in the ground matrix. So, it is a composite structure in which we have concentric layers of fibrocartilage within with annular fibers embedded in the ground matrix. The nucleus pulposus contains loose fibers suspended in a gel with the consistency of a jelly. It has high water content and it resists axial loads. The strong composite of the annulus fibrosus ground matrix and the annular fibers encloses the nucleus pulposus that helps to distribute the pressure evenly throughout the disc. Let us now discuss about the ligaments of the spine. The ligaments are strong fibrous bands of connective tissue that holds the vertebra together and provide stability to the spine within its physiologic range of motion. So, the ligaments provide stability to the spine. Excessive movements such as hyperextension or hyperflexions are restricted by the ligaments. There are actually 7 types of ligament which are shown in the figure: anterior longitudinal ligament, posterior longitudinal ligament, supraspinous ligament, intraspinous ligament, interspinous ligament, capsular ligament, intertransverse ligament and ligamental flabum are the 7 ligaments in the spine. The movements of the spine needs to be discussed. The movements offered by the spine are flexion and extension in the sagittal plane. So, front and back is extension, bending front and bending back is flexion and extension in the sagittal plane. Bending, lateral bending to the left or to the right in the coronal plane is a movement offered by the spine, and the third movement is the rotation of the spine towards left or towards right in the transverse plane. Now we will discuss about each section of the vertebral column or the spine, starting from the cervical spine, its structure and function. The cervical spine is the most superior portion of the vertebral column that provides mobility and stability to the head while connecting it to the relatively immobile thoracic spine. So, the cervical spine consists of the vertebra C1 to C7, and it is the topmost part of the vertebral column. So, one of the cervical spine between C3 to C7 is the shape is shown, a vertebra, cervical vertebra is shown here on the right. The range of motions of the cervical spine offered by the cervical spine or in the cervical spine, the range of motion in the cervical spine are flexion 80 to 90 degrees, extension about 70 degrees, lateral bending 20 to 45 degrees, and rotation 90 degrees both ways, towards left or towards right. Let us now discuss more in detail about the atlanto-occipital joint in the cervical spine. The atlas C1 is the first cervical vertebra which articulates with the occiput, the lower portion of the head, the skull, on one hand, and the second cervical vertebra axis C2 on the other. Let us now discuss more about the thoracic spine, its structure and function. As shown in the figure, we see the thoracic spine consists of vertebra T1 to T12. The structure of a thoracic functional spinal unit as well as one vertebra is shown on the right hand side. The main function of the thoracic spine is to hold the rib cage and protect vital organs like the heart and the lungs. There are 12 thoracic vertebrae in the humans, and these bones increase in size and mass as we move from T1 down to T12. The increase in size and mass ensures more support to the weight of the body. The range of motion of thoracic spine is very restricted due to joint articulations. Let us now discuss about the lumbar spine, its structure and function. The lumbar spine is located towards the lower portion of the vertebral column as shown in the figure, and the main function of the lumbar spine is to bear the weight of the upper part of the body and transfer the forces and bending moments to the sacrum and further to the pelvic bone. A typical structure of the lumbar functional spinal unit and a structure of the lumbar vertebra is shown on the right. The vertebra in the lumbar spine are much larger in size in order to withstand heavy loads during various physiological activities. The lumbar spine is more mobile than the thoracic spine and also carries more weight, making it the most likely region susceptible to injury in the spinal column. The range of motions offered by the lumbar spine are combined flexion and extension 40 to 90 degrees, lateral bending towards left or towards right 20 to 45 degrees, and rotation both ways 5 to 15 degrees. Let us come to the final topic, the degenerative disease of the spine. On the left, we can see the image where reduced disc height has been presented, and on the right it actually proceeds towards osteoarthritis in the facet joints. The symptom of this degenerative disease are back pain or neck pain, and it is also associated with stiffness in the spine. This is common in cervical and or lumbar region of the spine. Degeneration actually means a specific injurious change in the composition, structure and function of the spine. This degeneration leads to disc dehydration, reduction in disc height as indicated in the figure, and disruption of outer annulus lamellae, as well as appearance of crack and fissures. With more severe disc dehydration and reduction in disc height, more load is carried by the facet joints as compared to the healthy spine, eventually leading to facet joint osteoarthritis. The different stages of the degenerative diseases are plotted one by one. We start with the stage 1, where we see a homogeneous structure of the intervertebral disc, and the disc height is normal at the first stage. In the second stage, a very important stage, where inhomogeneous disc structure is visible. The inhomogeneity sets in within the intervertebral disc. However, still the disc height is within normal limits. In the third stage, we see a complete inhomogeneous disc structure. Still, the disc height is within normal limit. In the fourth stage, we see in the inhomogeneous disc structure, the disc height has started to reduce. So, there is reduction in the disc height that sets in at the fourth stage. Finally, in the inhomogeneous disc structure, the disc has collapsed. The treatments can be two types for the disc degenerative diseases. The first type is the conservative type of treatment, which includes physiotherapy and medicine, combination of physiotherapy and medicine. But there is also a surgical treatment. There are two types of surgical procedure. One is the fusion, another is the non-fusion, as shown in the figure as well. In the fusion surgery, the surgical procedure involves fusion of two adjacent vertebrae. So, from the word itself, it involves fusion of two adjacent vertebrae using interbody cages and pedicle screws. Whereas the non-fusion type of surgical procedure involves replacing the intervertebral disc with an artificial intervertebral disc, as shown in the figure. The lecture is based on few references as shown here. Thank you for your listening.